All right, this is part 2 of trig equations. In some ways, this problem here may be easier than the one in part 1. Part 1 really is getting the basics of understanding the unit circle, the unit triangle, the reference angle, all that business, but all of these problems have the same ending to them. This is a problem where you don't know where to start because some of you are not comfortable with cosecant, and you can't use a calculator on this one because let's see, cosecant is not equal to sine inverse. Okay, so those of you say, well, I have a button on my calculator called sine inverse, and that is not equal to cosecant. All right, so just be careful with that. That is a big misconception. No. All right, so once again, like the other equations, you're going to isolate the variable here. So we're going to subtract 1 and divide by 3. So we get 6 divided by 3 is 2. Now, the reciprocal of cosecant is sine. So this is equal to 1 over sine. By definition, that's what it's equal to, is equal to 2. Now all I'm going to do is I'm going to take the reciprocal, I'm going to flip both sides of the equation. So 1 over sine, if I flip that over, I get sine on top. If I take the reciprocal of 2, I just flip that over, I get 1/2. I think I've seen 1/2 on that unit circle paper. I see a lot of them. So I've just got to go hunting for that. Now sine is associated with the y value, all right? And this is positive. Sine is positive in 2 quadrants, so we're going to have 2 solutions. So once again, I'm going to go hunting for y is equal to 1/2 on the unit triangle paper. So here we go. Y is 1/2. Here's a 1/2. Oh, that's the x value. Y is 1/2 here, and y is 1/2 here. Now y is equal to negative 1/2 here, and negative 1/2 here. But this is strictly positive. I didn't square root both sides. I don't have a plus or minus scenario. I just have positive 1/2. Sine is positive here and here. So now I'm ready. And notice again, it's a 30, 60, 90 triangle. 30, 60, 90 triangle here. The reference angle is 30. The reference angle here is 30. But our solutions is 30. Because it's in the first quadrant, so we get pi over 6. And the other one is, we're going to start from 0, and we're going to swing on over to right there. That's 150 degrees, or 5 pi over 6. 30 degrees, 150 degrees. Sine's positive in 2 quadrants, 2 solutions. Done. All right, let's go to the hardest type of problem. This involves factoring. And here we see 2 different trig functions, a sine, a cosine, lions and tigers and bears, oh my, sines and cosines and equations, oh my. So what we're going to do here is we're going to eliminate one of those 2 using an identity. So once again, this is a very algebraic exercise here. This is called the Pythagorean identity. You need to memorize it. It is a fact. It is your best friend when it comes to trigonometry. Anytime you see any of these squared pieces, you can interchange them. You can substitute for each other, okay? So if I have the original problem has a sine and a cosine in it, I can get rid of one of them and have it only in terms of sine or only in terms of cosine. Now, one important note here is this only works with squared pieces. So this is not true. This is not true. Well, it is true that they're not equal to, but sine plus cosine is not equal to 1. A lot of students just think, oh, I just take the Pythagorean identity and I square root both sides. And no, you can't do that because the square root of a sum is not equal to the square. The square root of the sum is not equal to the sum of the square roots. So leave this thing alone. It only works with squared pieces. So just get this out of your head, all right? All right, so since it only works with squared pieces, in my original problem, there's only one squared piece. It's right here. So that means I need to figure out what cosine squared is equal to. If I take the Pythagorean identity, okay, I take the Pythagorean identity and I subtract sine from both sides, which means I want to get this by itself, which means I'm going to subtract sine squared from both sides, and I get this. All right, so cosine squared is equal to 1 minus sine. So all I'm going to do is I'm going to take this and I'm going to substitute it in the place of cosine. Plop. So 1 minus sine squared goes here. When I distribute the two, I get this and this. So notice we have a squared piece, a non-squared piece, and then a constant. So this is very similar to a quadratic equation from Algebra 1. So I'm going to move all the pieces to the same side. So since this is a minus 2s squared, I'm going to add that to both sides to put it on the left, so it's positive. And this is a positive 2, so I'm going to subtract 2 from both sides from the 1 to give me a negative 1. So all I'm doing is I'm moving all these pieces that are on the right. I'm moving these pieces to the other side of the equation to give me 0 on this side, okay? Because there's something called a zero product property, which means that if you have two things that multiply to get 0, one of the two things have to be 0, okay? So that is a powerful little tool in algebra and in these trig equations. So I set the equation equal to 0. Notice I have a quadratic, a trinomial here. And if you don't know how to factor this, that's a whole nother ball game. In this video, I'm not going to show you how to factor, but you're going to have to learn how to factor these. Otherwise, you can't do these problems. Alrighty, so I got 2s and s, and I think this is a plus 1 and a minus 1. Yep, that works. All right, so if I have two things multiply to get 0, which means that the first thing has to be 0. So I'm going to take this guy over here. So 2s minus 1 equals 0. I'm going to add 1 divided by 2. Hey, didn't we do this problem? S equals 1/2. Yeah, right here. It's the same ending. So sine's equal to 1/2 at pi over 6 and 5 pi over 6. Sine's equal to 1/2. I already solved that one. Pi over 6 and 5 pi over 6. So sine is positive in 2 quadrants. Here, sine is the y value, pi over 6, 5 pi over 6, done. I did not plan that, but I recognize that I just done it minutes ago. And then if we take the other one here it says sine plus 1 is equal to 0. I'm going to move that over here. In this case, to solve for sine, I have to subtract 1 from both sides. So sine's equal to a negative 1. Sine's equal to negative 1. Sine is equal to the y value. So I'm going to find on the unit circle where y is a negative 1. Let's go look for it. Negative 1, we get a positive 1 there. A negative 1 there, but that's the x value. That's where cosine would be equal to 0. I want to know where a sine equal to negative 1, which is the y value. That's at the south pole, 3 pi over 2. So the last solution here would be 3 pi over 2. So this guy yields, the orange one yields one solution, the south pole. The gold thing over here yields 2 solutions. So this is an odd question because it yields 3 different solutions. Most trig equations only have 2, or sometimes they have 4. This one has 3. And you may encounter other questions on trig equations, but these 2 videos that I just made is 90% of what I would like you to know. There are some subtle little differences out there, but I try to give you 4 examples that show you all the different types of equations you're going to encounter. All right, take care.